So in today's class, uh, first we are going to see about that linear regression problem, like how they are finding the error, absolute error, square error and other things. What is the difference between different error types, which to use where? Those things we will be seeing now. Then we will see one project related to that. Let me share my screen. So yesterday I was talking about this simple example only. So we are having months and then actual demand and then uh, forecasted demand is there. Okay. So here what I will take it as X value. We have talked about X, Y and other things, right? So which will be my X and which will be my Y? So month is going to be, yes, month is going to be my X and Y is going to be my demand. So in the demand part, actual demand means the point which I have plotted is the actual demand. Okay. And the forecasted demand means the demand which has been predicted by our model. Okay. So first actual demand is there for every month we have got, and then we have trained our model and tested and predicted the values, and these are the predicted values we can say. Then what will happen is we need to find the difference between the actual demand and the forecasted demand. So if you are simply subtracting from the actual demand and forecasted demand means this is how we will get right error. So what is the difference we are getting? That we call it as error, right? So here we will be getting a negative value also as well as positive value also. So here some cases it may be predicting the exact value. So that will become 0, right? Here we don't need any negative value. We just want to know the difference between the actual demand and the forecasted demand, right? So for that only we are converting all the errors to absolute error. So absolute error means what? All the negative values also will be converted to the positive values. So we know the function for that, right? We used to give ABS, and then if you are putting the value inside, negative value means it will return it in the positive value only. So like that, we are applying that in all the values which we have got. Then we are calling it as the, yes, any doubt is there? We are calling it as the absolute error. Okay. Then the next step will be we have to find the mean. Mean means like average. On an average, how much error our model is getting than the actual value. So to know that, just a minute. uh, to know that we will be adding all the values and dividing by total number of values. So here we will add the value and divide by 12, right? Because we are having 12 values. So this is the mean absolute error. Okay. So all this by default we will be having one function in our I mean module itself. So we don't need to do each and every step step by step. But this is how it will work. If you are using the function means in the back end it will work like this only. It will compare both actual and forecasted value. Then it will find the error. Then it will convert it into absolute error. Then it will find the mean of that all the errors. Okay, so here what will be the problem is if you see the numbers. Okay, this is simple step, first step we can say. If you see the numbers means is numbers looks like very small numbers only, right? So it is not possible to find a big error in this particular values, right? We can say out of this which is the maximum value means I can say 5, but still 5 also looks like small error only, right? It is not like very big. So to find out the outliers, or whichever points are creating a lot of error or affecting our data set, those type of values we want to find it out. So for that, what we will do is we will go to the next step. So in the next step, what we will do is we will try to square all the values. Okay, when you are squaring all the values, now see this values. By seeing this value, what you can say? You can easily point out which are the points are creating problem or outlier present in our data set. So that can be removed or converted into some other values, mean values. We are finding some mean values, right? So in that way, 1.83 is there. We can convert it into 2 also, or 1. Any extreme we can go. So if I convert, that means again if I'm checking means what will happen? My error will be reduced, right? My accuracy also will be increased automatically. So this is how it will work. Oh, sorry. Uh, so if you see the graph means the line which has been created is by our model, and we are finding the difference. The error difference is there, right? Assume that these are the points. Okay, for one. So for this will be the 1 point, and here another 1 point. Like that, forecasted points I will be plotting. Okay, so we need to find the difference between the actual and the forecasted value. That is what we are calling it as error. Okay, as another step, what they will do is, so they will try to find the square root. Okay, first we are squaring the value and we will take the square root of that particular value. Okay, sometimes while if we are doing like this means we will be getting different answers also. Okay, so we will see the difference between like using the MSE or RSME or MAE. MAE means mean absolute error. MSE means like from the reverse if you are reading means error, and then you will be finding the mean and then square and then you will find the root. Okay, first error we will find, then we will find the mean like absolute mean, and then we will square it, and then we will find the square root of it. Okay, so based on square of error, it will work. First thing. So if you take only the mean absolute error means based on the absolute value of error, it will be predicting. So when you go for the R2 score, we call this as R2 score. So this also we will be checking how much difference is there in R2 score, how much percentage we are getting, and in MSC how much percentage we are getting. Like that we will compare. So how R2 score will work is based on the correlation between the actual and the predicted value. So how much it is related to those two values, it will be giving you the result. Okay, here if you see the range which range to which range you will be getting output is for MSE and then MAE, the value will be till infinity, 0 to infinity it is possible. Infinity means any number it is possible to get it as our output. Right. Whereas if you go to the R2 score means output will be lying between 0 to 1. Okay, 0 to 1 means 0 is coming means no any difference is there, because actual value also in this example also we have seen, right? Actual value also 60, um, predicted value also 60. So obviously I will be getting 0 only as difference, right? So that will be my minimum value. Completely difference means we will be getting 1 as our maximum value. So since it is between these particular range, it is easy for us to predict also, right? 0 to 1 means it will be like if I say 0.2 or 0.6 means that much error or difference is there in our actual and the predicted value we can say. Right, that is another one difference. Then third difference is sensitive to outliers. So I have told, right, if any outlier is there means And if I'm trying to plot this value means this 25 will be plotted very distance from our actual pattern, right? So if more outliers are present in our data means it will be difficult for us. The accuracy also will be affected. Okay, so it is sensitive. Here, treat larger and small errors equally. Okay, not sensitive to outliers. So again, if you see this particular thing means even 5 also very small value only, right? Even if I'm getting 5 10 also, if I'm trying to plot means it will be very closer to each other. There is no any big difference will be there. So that is what mentioned here. Even a small value or a large value also, outlier, we will not be getting much outlier. Okay, when you go for R2 score, not sensitive to outlier. Why? Because value is going to range between 0 to 1 no matter what is the actual value. Right? So 0 to 1 range only means it will be always between that range only. So we cannot say this point is an outlier point. This point is not an outlier. Like that we cannot say. So we are saying it is not sensitive to outlier. Okay, then another difference between these three is small values indicates better model. Okay, here small values means 4, 1 and all small value. 25 means larger value. So obviously small values are best values we can say. Here also small values indicates the better model. So if I'm having 0, 1, 2 like that means I can say only small difference only is there, right, in the actual and the predicted. So we can ignore or negotiate those values. Okay. Whereas here if you come to the R2 score means the value near to 1 indicates better model. Okay. So it is similar like percentage. 0.2 means 20 percentage accuracy, 60 percentage. So how close the value is. So if I'm getting value like 0.8, it means 0.86. Like that we will be getting to multiple points. 86 or 0.93. Like that if we are getting means we can say our model is a best model in R2 score. Okay. Then so based on that, we will be finding the confusion matrix. So we have seen about confusion matrix, right? So here we have already seen actual values there and then predicted values there. So if both are same, actual value and the predicted value are same means then it will come under true positive. Both are negative means it comes under true negative. If actual is saying false and predicted is saying something else means it will come between these two values. So we have to try to reduce these values and to increase this value and to know the accuracy how much accurate our model is. We just have to apply the numbers which we are getting in this confusion matrix into this particular formula. So TP, so first TP value we will take for assumption. If 20 is there, 30, here 10, here 40 is there. So if you count all the values means you should get the total number of rows present. Okay, because all the rows it is going to check, right? So if I add all these values means because that is going to be our denominator, TP plus TN plus FP plus FN. So 40, 80, 100. So totally I'm having 100 rows like that you assume. From that I'm going to take only TP plus TN, which means TP is 20 and TN is 40. So I will take 60. So what will be my answer? So 0.6. So I can say my model is having 60 percentage of accuracy. Okay. So based on this, let us see one example program or a problem we can say. Okay. So what we are going to predict in this model is, so first we will see what project or problem we are going to see. So we are going to predict the marks obtained by a student based on the hours of study. So how much you have studied, that we are going to collect, and how much marks you have scored, that we are going to collect and train our model. Only two columns we are going to take and perform this operation. So first question is, first step we can say, finding the problem. So what problem you are going to solve? So you are going to predict what mark the student will score. Okay, so new hours, if I am passing, means it should say for that particular hour what will be the score that student will gain. Okay, and second step is collecting the data set. So we know what is the output we need, what is the input we need. So based on the number of hours students studied and then how much they have scored, it is past data. Okay, previously how much hours a student has studied and how much he has scored in the final exam. Those data we will be collecting in the form of CSV file. Okay, so if you open that particular file, means in Excel, if I open, means it will look like a normal Excel file. Uh, okay. Whereas if I am opening it in Jupyter Notebook, means since it is in an .csv format, it will show like a comma separated value only. Okay, when we are seeing the data set, I will show you how it will look. Okay. Then what will be our third step? We have to load and summarize the data set. Okay, we will not know how many data are present and other things, right? So we will load the data and we will check head, value, tail, and some summary, like what we can say. We can check for the information. If you give information, means what are all the columns are there and what are the data types it will display. And we are having description. Okay, if I give describe, means it will give some description about each and every column. So those information we can gather. So loading the data from our directory, so either you can use relational path, I'm sorry, relative path, or the absolute path to import the data set. Okay, for summarizing purpose, we will check number of rows and columns, what is the content present inside, so everything we will see. So for that, these are the methods we are having. These and all we have seen in the Panda itself, right? So we will be importing Panda, NumPy, and along with that we will be importing scikit-learn also. Okay, so data set here, for simple syntax, I have given like data set equal to pandas dot read underscore csv. So in the codes we will be giving the dataset dot csv file. So first step. So to know the number of rows and columns, what we can give, simply if I give dataset dot shape, what will it will return? It will return two values, right? Row comma value it will return to me. And then for display purpose, like first five rows if I want, means dataset dot head. If I simply give head also, it will return me five rows. If I want more rows to be seen, then I can specify the value also. Okay, so this is going to be my third step. Okay, then in my fourth step, I'm going to segregate the data set into X and then Y. Okay, so X and then Y. So we are in this particular data set, X is going to be my what? Number of hours a student has studied, and Y is going to be the marks which has been scored by that particular student. So here what I can use, I can use ilog, because we are going to separate based on the index numbers, right? So it will help you to separate a value that belongs to a particular row or a column. So I am going to use ilog here. Then this is how my syntax will be. So x equal to dataset dot ilog. So this will be helpful for any dataset. If I'm taking, I can use the same syntax. So here first next value represent rows, right? So I'm going to take all the rows. To mention that, I will simply give colon comma, so all rows. And then I don't want all the columns, I want only uh, columns, mean without the last column. Always last column will be the output column, so I'm leaving the last column. So I'm just uh, giving the -1 here. Okay, so it will take remaining columns as x. Okay, and then I'm just giving dot values, so all the values will be passed as my x variable. And for y, I want only the last column, right? So I will give -1 alone, I will not give colon -1, simply I will give -1 in the column area. So row, again I want all the rows, dot values. Okay, so all the values will be passed to my new data, I mean new variable called y. Okay, then in the next step, so fifth step, what I'm going to do is splitting the data set to train and test. So yesterday we have seen, right, we will be splitting the data into two halves. One is for training purpose and another one is for testing purpose. So for training, we will be taking like 80, more than that, 80 or 75, 70 also we can take. Okay, so use it for validation. Remaining 20 or 25 percentage, we will keep it for validation purpose. Okay, so this is going to be the syntax for uh, the training and testing data split up. So this particular function is present inside our scikit-learn only. Okay, so that I will show what is the import syntax what we have to give. From that, we are having one function called train test split. Okay, this will split the values into separate for training testing, which means like yes, x test, x train, y test, y train, like that. It will split it into four halves. Here the parameter we have to pass is test size. How much percentage of data you are going to take it for testing purpose. So here I have given it as 0.25 percentage, which means 25 percentage of data I am going to take it for testing purpose. Then another one parameter I have given is random underscore state is equal to 0 I have given. You can give any number. Okay, the purpose of giving this random underscore state is each time what will happen is it will be taking in this if I don't specify random underscore state, what will happen is each time it will be taking a different set of values. So our output will be differing each time when you run the program. So to avoid that, you want a same split up. If I give random state is equal to 0 in my program, and you people are also giving the same random state is equal to 0, means whatever output I am getting as my final accuracy, same output you will also be getting, because it will split the data set in the same order, no matter how much time you are running that particular uh, program. Okay, because sometimes you have to repeatedly run this program, right? Some errors coming means you will be running from the beginning. So that time, what random state value you are giving, based on that it will be splitting the value into train and test. Okay, here if I give 0 and if you are giving some other value, means it will split the value in different pattern. Okay, so we can give any number like 0, we can give 1, 2, 3, 4, whichever convenient we can give, but depend upon that our output also can vary. Okay, it will take randomly 80 percentage, it will not be in an order. Okay, 10 rows is there, means first 8 alone it will not take all the time. Based on the random state it will change, but it will be fixed. One random state number you have given, means based on that it will split. Same number if someone else is also giving, means same split up will happen. For the reason only we are giving this random underscore state. Okay, then in the sixth step, So feature scaling I have given. Okay, in the problem, the current problem we are going to deal, what are the values will be there? uh, Only one column is taken for x and one column is taken for y, right? In that, so no problem, we don't need to do any feature scaling. But later on we will be dealing with multiple columns, right? That time we just have to perform one more step, that is nothing but feature scaling. So I have told about this feature scaling also. So do you remember what are all the methods we will be using for feature scaling, or why we use this feature scaling? Can anyone say? From this example also you can say we are having name, weight and price. Obviously we don't need to know the name in case if it is a different data set. So weight and price is there. So why I need to perform feature scaling in this particular data set? So why? Because weight is in different unit and price is in different unit. So weight is in kilogram, right? So it will be like lesser value, and price will be in rupees, right? So it will be in greater value. So what problem we will face? Okay, if it is in different units means, since both the feature have different scales, there's a chance that higher weightage is given to the feature with higher magnitude, which means our model will focus on the price part, because here I have given price as 1, 3, 2, 5, which looks smaller, and weight looks like 15, 18, 12, 10. So if this data I am passing means weight column will get more weightage than the price column. But in real scenario, weight will be less, right? 1 kg, 2 kg I will be saying. But if I see the price means it will be like 100 also will be there. Some cases 1000 also will be there, right? So to avoid that, so this will impact the performance of our machine learning algorithm. So we do not want that our algorithm to be biased. So automatically what will happen? It will be focusing on this particular column value alone. So it will be a biased output. So to avoid that only, we are going for the feature scaling method. So we scale our data to make all the features contribute equally to the result. So after feature scaling, this is how I will get the output. Okay, zero, I mean it will be like negative value and also positive value also, depending upon what type of feature scaling you are performing. In one feature scaling, I have told it will be ranging from 0 to 1 only. In another feature scaling only, it will be positive or negative numbers will be there. So what are the types we have seen? So we have seen two types. One is standardization and second one is normalization. So whether in standardization or normalization, in which part we will be getting values ranging from 0 to 1? Can anyone say whether in standardization we will get 0 to 1 or normalization we will get in 0 to 1? So in normalization only we will get, right. So the formula for standardization is x minus mu by sigma. Okay, so anything you can say, or simply x minus mean value divided by the standardization value. Okay, so here the value are centered around the mean with a unit standard deviation. So divided by standard deviation and subtracted by, yes, mu mean that mu is there, right? That will be the mean value. I have showed you the diagram also. I mean, that Excel also, right? First, we are finding the mean, like that. So, we will find the standard deviation also. Okay, and we will substitute in our formula. So, again, this also we don't need to do separately. We don't need to find the mean or standard deviation and apply in the formula. Simply, if you are using the standardization method, in which is an inbuilt function will be there. If you are using standard scalar will be there. So if you are using means automatically it will perform all the operation to those columns and it will return a new data set. Okay, so this is one thing. Then normalization. So if you go to the normalization means x minus x minimum. So what is the minimum value is there? That I will be subtracting. Then divided by maximum value minus minimum value. So difference of maximum minus minimum. So for each value I will be performing this operation. So if I do that means, so this we call it as min-max method also. The another name of normalization is min-max method. So normalization is a scaling technique in which the values are shifted and rescaled so that they end up ranging between 0 and 1. So values always will be between 0 and 1 only. So as I told, it is also known as min-max scaling method. This is standard scaling method and this is min-max scaling method. Okay. Then seventh step, only four more steps are there. So in the seventh step, what we will be doing is algorithm. So what algorithm we are going to use? Linear regression algorithm we are going to use. Okay, so we can use one or more independent variable to determine the dependent variable. Okay, in this case, I mean the predicting the score of a student, we are taking only one dependent variable, and based on that one dependent variable we are going to find the independent variable. Okay, then training. So for training, like train our model for the pre-processed data set. Already data set has been splitted, right? The method we will be using is model dot fit. So here model I have given, we can give different name also. Okay, whichever variable you are storing that particular class. It is model is nothing but an object created for that particular linear regression algorithm. Okay, so for in that object we are having one function called fit. So there is some difference between fit and fit transform is there. That also I will explain. As of now we are giving for training purpose, we have to pass the data set into our model, right? So for that we will use this method called fit. Inside that we will pass both the x train and y train values. Okay, once the training has been completed, okay, once the training has been successfully completed, then we will validate the uh, model. Okay, to obtain the actual I mean accuracy of our model, what we will do, we will find the confusion matrix. Okay, so again for this also we will be using a method. Okay, in that method if you are passing the y predict and y test value means, so you will be getting some output like this. Then my final step will be prediction. So for prediction I have to pass that y train value. Okay, or we can pass the new value also. Okay, in our case we will see how it is possible. So what we will do is model dot predict and then x test or test value we will pass, and then we will expect the um, output from our model. So forecasted values we have seen, right? Similarly we will be expecting some output from our model. Okay, after this only, like after predicting only, we can do the confusion matrix. Why? Because what value predicted by our model, that we need to know, and what is the actual value that we already know. So based comparing both only we can perform this confusion matrix. Okay, so let us directly go into the programming part. So let me share my so if you are opening it in the Jupyter notebook, this particular data set, this is how it will look like, comma separated value. Okay, so first column represent the number of hours they slept, and the second column represent the marks they have obtained. So 0 hours means he didn't study anything, and without studying he has scored he or she, anyone we can take, scored 34 marks. So 1 hour they have studied means 36 marks they have scored. Two for 2 hours we are having multiple values. See, one person in 2 hours he has scored 45 marks. Same hours someone else has studied, but he or she has scored only 38 marks. Like that we are having various values. Totally we are having 30 values. Okay, 31 means first row is the heading, right? Hours and marks. Remaining are the values. So I have also created some template. Okay, instead of again and again creating. So this is how our template is going to be. So first we will be importing the library, then loading the data set and summarizing the data set, segregating, splitting, feature scaling. If there means we will do the feature scaling, training, and then predicting, and then finally evaluating our model. Okay, here the feature scaling step we will not be doing. Why? Because we are having only one column, and that column unit only we are going to use. So no need of going for the feature scaling. Okay, remaining step we will be doing. So first import the libraries. So basic libraries only I am going to import Panda and NumPy. Okay. So before that, you just check whether the scikit uh, learners installed in your Anaconda or not. Okay. So if not installed means you can install it. Just a minute. Okay. So one more thing is, if you want means the current version of Python which I am using in the Jupyter notebook will be 3.9, that latest version, right? But later on, in some cases, mostly in machine learning, I assume you will not be getting any future warning error or any error. But in case later, if you are going for a further algorithm, if any future warning error or something is coming, means we can. Right now, I'm not switching, but if you want, means you can switch to the older version of Python and you can create a new virtual environment. Okay, I have already taught you how to create virtual environment in Anaconda, right? Using the GUI itself, we can easily create. So that also I will just show. I'm using 3.9 only, so you can use it as it is. No issue. Sorry, Anaconda Navigator. So by default, the psychic learn also will be present in your what to say, your Jupyter notebook if you are using the default base virtual environment. Okay, otherwise you have to go to the environments and you have to create. In the bottom you can see the create, right? So here also I have created Python 3.8. I cannot give symbols while creating the environment name, so it is written as py 38, which means in our assumption 3.8. So easily we can create and we can switch. But if we are switching means automatically and all, Jupyter notebook will not switch. 2 3 steps we have to do. Okay, and all the packages which is present in our base, which are root virtual environment, will not be present in our new environment. We have to install all the packages by ourselves. Okay, you can directly install from here also. For example, in Python 3.8 I'm going means I have installed by myself. Okay, if you want means you have to install. For example, Panda I have not yet tried. Just a minute. So just to show it to you only I have created this. So install only it is showing, right? Just change it to all. Okay, and you can search for the packages. Okay, so I'm just searching for pandas. Right, so here pandas is there. I have not yet installed the panda in this particular virtual environment. So simply you can just click that checkbox. Multiple checkbox also you can select at a time, and then you just have to give apply. Okay, so it will load and then it will be added into your virtual environment. Sometimes it will, what it will say is this particular version is not supported, like you have to downgrade, or from this version to this version only it will support. Like that it will give some warning to you also. Okay, so in that case, so okay, I will just install it. So the version you are installing in pandas is 1.4.3. Okay, if you are trying to import the panda and performing some operation and it is throwing any error, okay, I will not support the latest version. I will support only 1.4.1 or 1.3.9. Like that, if you are getting any error means we can downgrade this Python also. So simply if you are clicking, right click. Okay, if you click means, see here, mark for specific version installation also it has given. So whatever version available starting from the first version 0.20.3 to latest version it is available. So 1.4.2 is there because already 1.4.3 has been installed, right? So you can downgrade your version also. If it is throwing any error, only 3.5 only supported, maximum version means you can just click that and you can apply. Okay, right now I am not giving anything. For example, for NumPy, if you are installing scikit-learn in the 3.8, so scikit-learn, see here, scikit image, scikit-learn and all will be there. You just have to install scikit-learn. If you are installing scikit-learn and importing the NumPy means, obviously it will throw one error. Okay, so to avoid that error, what I did is I have downgraded my NumPy. So NumPy and NumPy base, both I have to downgrade. So I have downgraded, that's why it is showing like this. Because the latest version is, see, it is showing like update available. You should not update it. Okay, so if you check the latest version means it will be more than 1.2. See, the latest version is 1.23.1. Okay, but I have installed only 1.22.3 to avoid getting warning. It will be like warning later on if you are going for any complex function which is not present in our older Python. Older Python may not be supporting that particular function. That time you will be getting some error. So these are the few things you need to consider before going for any new virtual environment. Okay, so let me be in the base version itself as of now. Okay, so let us get back to the program. It is clear for you all, right? If you are creating one new virtual environment means either using the like either you can okay, for example I will show that also. From terminal you want to install the packages. Pip install you want to give means what you need to do is, see currently I will just open the new terminal. So in the new terminal if you see means already it is in the base virtual environment, right? So first step I have to come out of this virtual environment. So for that what I have to give? I have to give conda. Okay, just conda deactivate. Okay, wait. So then we have to activate the new virtual environment. So conda activate, and then you have, see previously we will not specify the uh, environment name because by default only we are having one environment and it will take that particular environment as, but now we have to specify for which virtual environment you have to enable. So I have created like Python 3.8, right? So if I give enter means, see it has been entered into that environment. So if I go and type Python, see my Python version is 3.8.13. Okay, so now if I try to import pandas, in this particular okay, I have already installed, right? In front of you only I have installed, so no problem, it is accepting. Scikit-learn also I have installed. Okay, matplotlib, I will check with matplotlib. See, it is throwing error like module not found error. No module is like map because it has not yet been imported into our this particular virtual environment. Okay, okay. So I'm just uh, so if you are inside this Pi 38, okay, new virtual environment means you just have to Jupyter Notebook also will not be available. It will show like Jupyter Notebook will be there. Okay, here it is there, right? Instead of showing like launch, it will show like install. You have to install then from the new environment. Otherwise, will create it for you. Okay, one new environment, completely new. I am creating. So I will give like Python 38. Okay, 3.8 I'm giving like 38. Here you can specify the Python version. What Python version you want. You can choose 3.8 or if you want means you can choose 3.7 also. Not a problem. Okay, I'm choosing 3.7. So I'm just changing it as 37. Okay, so if I give create means, so it will be created here. Okay, now it has been created, right? So if I go to the home means, see here if you check means, what it is showing, it is instead of showing install, I mean instead of showing launch, it is showing like install. Only if you install only, you can able to use this Jupyter Notebook. Okay. So if you don't want this particular environment anymore, okay, you have created but you have not used it or you don't want it anymore means simply you can remove this particular environment. So along with it, whatever package you have installed in that particular environment, that also will be removed. Okay, so I'm just removing it. Only if you are launching the Jupyter Notebook from that particular environment only, it will be loaded like that. Otherwise, two more commands will be there like ipython, some commands are there. Using that also you can include all the virtual environment in the same Jupyter Notebook itself. See here new is there, right? If I click new means Python 3, this alone it is showing, right? This is default one. Here itself we can add multiple virtual environment also. Okay, currently I'm not using the 3.8, 3.9 only I'm using, but later on if any issues coming for you or me means I will be switching to 3.8. So when I'm switching, I will inform you. Okay, so as a first step, import the libraries. So I'm just importing pandas and then numpy as np. Okay, whether you are using or not using, simply just import this. Maybe somewhere it will be helpful. Okay, by default pandas is needed because using the panda only we can read the CSV file. Okay, so I will not by numpy. Then load the data set. So my data set is present in the same location only. My data set name is 01 student.csv. Okay, so for that, so I'm just giving data set. So pd dot read underscore csv. So student.csv file I have taken. Okay, this is going to be my original data set, right? So I'm going to take one copy of this particular data set. Copy means deep copy, separate copy I'm going to take, because later if I want to compare or any other operation I want to do means I need this original data set. Okay, I'm going to perform some operation in the data set, right? So for that what I will do is simply I will take a copy of it. So copy I will call it as df. So df is equal to, so for taking a deep copy, what we have to do, you should not pass like df is equal to dataset. We have to give dataset dot copy, copy method we have to use. So dataset dot copy. Okay. So this is what we are loading the dataset. Then for the summarizing the dataset, what we have seen shape and then head, right? So that only I am going to use it here. So simply I can give df dot shape, okay, and then if I give head, so first to five um, row alone I have taken. So by default it is giving the index, and see automatically it is taken first uh, column as the heading of my column. Sorry, first row as heading for my column. Okay, so 0 1, like their marks has been taken. Then next step what we have seen, segregate the data set into x, okay, which is going to be my input, or I can call it as a dependent variable, and y, which is going to be my output, or I can call it as a dependent variable. Okay, either you can use same caps x caps y or small y, no problem. So I'm using capital X. So capital X means, so how I have to split the data, I'm going to use the dot sorry, ilog method. Okay, so df dot ilog, same syntax which I have showed you in the mind map. So all rows I want, comma, all column except minus one. So if I give minus one means last column alone it will leave, so remaining column it will take. In our case two column only, so first column it will be taken. And for capital Y, I want only the last column, right? So simply I will give all rows, comma, minus 1. Okay. So x and y value has been taken. So if now if I go and check the x and y means, so capital X. See only hours alone taken separately. Similarly for capital Y, their marks alone will be taken. Okay. So here it is taken as data set. Here it is taken as series. Okay. Then, so x and y is there. Now, next step is we have to split the data set into train and test. Okay, here only I'm going to use the scikit-learn. Okay, in the actual name is we call it as SCIKIT, scikit hyphen learn. Okay, for importing we are having a short name for it, that is nothing but SK learn. Okay, okay, I think so from, okay, this and all you just note it down somewhere, because frequently we will be using this. From sklearn dot, inside the sklearn we are having one another one thing called class, we can say model selection. Okay, so in the model selection only we are going to import the train test split function. Okay, in the mind map you have seen this syntax, right? Train underscore test underscore split, and inside that we have passed the x and y values, so that I am going to import. So train test split. So if you are typing train and if you are giving tab itself, it will auto complete. Okay, no need to remember also. Now it will return, this function will return four uh, separate values. So that I'm going to store it in this particular order. So first x train and then x test. So that I will give it as x. So I'm using small x itself. Okay. So x train, then x test, and then y train, and then y test. Okay. Underscore, not. So equal to. So I'm calling that particular function train test split. I'm passing capital X, comma, capital Y, same syntax I have already shown you. So test size. Okay, what error does so text I mean sorry, test size I'm taking like in it was like 2 point sorry 0.25, right? So you can take 2 point I mean 0.2 20% or 30% also you can take it for testing. Okay, and then random state, we have seen another one parameter, right? Random state. So I'm just giving random state as 12. I mean 1 2, any number you can give. If I'm giving 12 means you are also giving same 12 means same split up will happen. Okay, I'm getting some error here. I think we will see what is happening. Okay, so without any problem, our train test split has been splitted into four different datas. So if I check all the four means, so in next train few values has been, see, it is not in an order, hours, and my index if you see means it is not in order, right? So randomly it is splitted, but each time it is split in the same order. Okay, x train, then x test. See, x test only 3, 4, 5, 6, 7, 8 values it has been taken for testing purpose. Okay, out of 30, 8 will be the 25 percentage, I guess. Okay, it will take only round of value, so 8 values it has taken. Then y train. Okay, so again same how much uh, 30 total 30, right? If 8 gone means 20, 23 I think, right? 23 or 22 will be taken for training purpose, remaining will be taken for testing purpose. Okay, this is the actual value. Okay, then here as I told, we don't need to perform any feature scaling because we are having only one column. More than two column is there and those two columns are having different units means then we can go for the feature scaling. Okay, otherwise no need. So this I'm just deleting, otherwise you will get confused. Okay, then we have to train our model. Okay, so again I'm going to import another one thing. Okay, from sklearn dot, now I'm going to use linear regression, right? So linear regression model, linear type will be available in linear model class. Okay, so sklearn dot linear underscore model. From that particular model, I'm going to import the linear regression. Here, L and R are caps. Okay, regression. Okay, both should be L and R should be caps. So this is the class name. So for this particular class only, we will be creating one object. So then only we will use that fit and other things, predict everything we will use. Okay, so first step, imported this particular value. If you want means you can import all this thing in the starting import libraries itself we can do, but each algorithm it will change, right? So that's why I'm giving it in that particular location itself. Okay, so linear regression I have imported, then I'm creating an object, for example student, uh, okay, student std, okay, otherwise stud I will give. Student is equal to, so linear regression. Okay, so now what is in the training part, what syntax we have seen, that model dot fit we have seen, right? Here if you want means you can give generalized term as model also, no issue. So here I have created student, right? So student dot fit. So what two things we have to fit? We have to fix, I mean fit the training as well as y train. X and Y I am going to pass it for my training data set. Okay, so if I run this means, okay, I am getting error. Cannot import name. Okay, okay, spelling mistake. Okay, Lenear. Okay, okay. So this is how I will be getting the. Okay, it will say like linear regression as my output. Okay, then next step is I have to predict for all the test data. Okay, our training has been over. Our machine learning started, I mean, learned the data. Now we have to test it. So for testing purpose, I mean testing in the sense predicting by giving only the x values alone. Okay, and it will return the y values. So for that, I will call this as y predictor. So predicted values, right? Is equal to student dot predict, and I'm going to pass the x test value, that 8 values we got, right? That alone I'm going to pass. So I have passed. Now if I go and check my y, okay, I'm just giving y. Y test also I'm taking. This is y test, which is actual value, and y predict. This is predicted value. Okay, so if you see means 45 is there and it is predicted as 50. 71 predicted as 74, 78 predicted as 69, then 72 as 60, 40. Okay, 36 means 40 it has predicted. Likewise, some variation is there. 42 means it is predicted as 40. So some close call only is there, right? Few places it is huge difference. For example, here 69, 78 is there, a huge difference. Whereas here very less difference only is there. Here also very less difference. Only one mark difference only is there, right? So what we have to do? We have to evaluate. Simply by comparing, we cannot come to a conclusion, right? So always remember, for regression type of problem, we will be checking mean square error. Okay, either we go for mean square error or some cases we go for root mean square error. There is no any direct method or function for root mean square error. To find root mean square error, we can simply find the power of 0.5. If I give for mean square error means it will be converted into root mean square error. So for that, again you notice I'm going to import another one, I mean these two what to say, functions from the another class. Okay, from sklearn dot metrics. So inside the metrics only you will have all type of evaluation methods. So from here I'm going to take, see, so many is there, mean absolute, mean absolute, percentage error. Okay, based on percentage it will find. So from there I want only mean square error. Okay, I don't even want a mean square log error also. Mostly we will be using mean square error, comma, R2 score, R2 underscore score you have to give. Okay. So to check the R2 score, like R score I'm just giving is equal to like R2 score. Inside that I have to pass y test, which is my actual value, comma y predict, which is the predicted value. So both if I pass and check my output means R score, if I am checking means, see, I am getting 84 percentage of accuracy. 84 means like 0.84 means it is 84, right? If I am multiplying with 100 and I am taking only last two values, I can say like that, right? Likewise, by changing the random state, I have taken randomly it has taken something. If I'm changing the random state or taking 80 percentage, I'm giving for training purpose and 20 percentage alone I'm taking for testing. Then again, our score can also be changed. Okay, this is nothing but a good score only, right? If you want means you can change with different score and also you can check. Now we will check for root mean square error also. Okay, mean square error, root mean square error. So this is like a percentage. 0.84 means like a percentage. 84 percentage we have got. Root mean square error means, okay, first mean square error we will find. So for that, if I give mean square error, again I will pass y test, comma, y predict. Okay. So it is showing like 35.8, like so, because it is mean square, right? When I squaring means it will look like bigger value. So you should not get confused. That is why we are going for root mean square. So if I take root of 35, what will be my output? 5 point something some will come, right? I will, that also I will check. So to find the root mean square error, all you need to do is just take the power. So if I give double star 0.5 means because power root means what, 1 by 2, 1 by 2 means 0.5. So that is what I have given like this. So if I run this now means, see, I'm having like 5.98 means this much difference will be there from my actual value and then predicted value. We have seen the Excel also, right? When we are checking the Excel, we have got 1.8. Then afterwards, I will share that also. Is it my what to say? Excel visible, right? See here, mean square error is there, right? Mean square error is showing 4.666. I'm taking root for this means 2 point something. So very less errors only will be there, right? Similarly, here also in my program also I'm having very less 5.9 error. That is why my accuracy is 84. Even if I'm getting less error means my accuracy also will be increased 84 to 90 or anything we can get. Okay, so I'm just storing this particular value as root mean square error, RMSC short form, or RMSR, anything you can give. Root mean square error is equal to, okay. Now we will plot and check, okay, how we are getting the output. Okay, in the Excel we have seen the plottings, right? So that plotting also we can check. So for plotting, we need to import a matplotlib. So import. Okay. So I'm going to create a scatter plot. So plt dot scatter. Okay. And then I'm going to pass x test and y test. Sorry, x underscore. Okay. Then I'm going to plot. Okay. So if I give plot means it will create a line plot, right? So I'm going to create a line plot for x test and y predictor, because x axis should be same for both actual value and the predicted value, right? Only y test, which means the actual value, and y predict is the predicted value, that alone has to be changed. So differentiate. So simply I will just give it like in single quote r, which means it will give it in red color. O, so it will giving it in points. So if I give colon means it will give some like dotted lines it will give. So finally I just have to give plot dot show. Okay. So let me run this and see how I'm getting the output. Okay, I'm getting type error. Where I have made the mistake. Invalid index error. Slice none, 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 none. Okay, in this line only it is showing error. Why? Can you see any mistake in this line? I don't get as in during handling the above exception, another exception added invalid index error. Ah, train test. Okay, this has been plotted correctly. Test y predict. Okay, let me check it and say, but up to here it is clear, right? Plotting, I have tried to show it to you. Before plotting, any question is there means you can put it in the chat. In the meantime, I will also check once where I have made the mistake. Okay, y predict. So finally, we draw the graph just to see like how actual values are plotted and how our predicted values are coming. So our predicted value will be in a form of linear line. Okay, to show you that only I have because in Excel also I have showed you, right, some linear line is coming. Likewise in the plot also some linear line will be coming. So some error is coming. I will try to solve it. What is the actual problem, and I will solve it in the next class. Okay. Apart from that, any question is there? Okay. No questions. Okay. So I'm winding up the session for today. Okay. Before winding up, uh, I will upload the data set. This data set also I will upload. And for practical, you will be, practical, you will be having another one new data set also. Okay. That data set, I will check and share it with you. Okay. Just a minute. I will show that data set also. In that new data set, you not only will have, just a minute. Uh, you will have totally three columns you will have. One is for hours and second one is for sleep hours, which means first we are testing with only the hours of studied and how much marks they have scored, right? Here new data set was we have taken. In that will check how much hours they have studied and how much hours they have slept. Okay, yes hours means sleeping hours. So if they got proper sleep or not, then whether there is any change in the score they have got, that we are going to check. So same steps, whatever steps I have followed, you will be going to follow here also, right? So here also you don't need to do any feature scaling. Why? Because hours both are in the unit of hours only, right? Sleeping hours also hours unit only, study hours also hours unit only, right? So you don't need to perform any feature scaling. So this data set also I will share it in the Vidya portal. So for this you need to perform the linear regression. Okay, and you have to say how much accuracy you are getting. Okay, that you have to upload it in the Vidya portal. Okay, clear. Okay, thank you all. See you in the next class.